Hello everyone. Welcome to lecture 15 of the ISC2 Certified in Cybersecurity Examination Preparation series. This lecture covers IP support protocols and cables. Agenda. Our agenda is to have overview of IP support protocols, detailed discussion of ARP, ICMP, traceroute, HTTP, HTTPS, DHCP, and networking cables, real-world applications and examples. ARP. ARP stands for Address Resolution Protocol. The function of ARP is to translate IP addresses into MAC address. Characteristics. ARP operates at the OSI data or network layer. It is simple and trusting protocol and anyone can respond to an ARP request. Security issues. ARP cache poisoning. It occurs when attacker sends fake responses to ARP requests. The countermeasure is to hardcode ARP entries. RARP or reverse ARP. It is used by diskless workstations to get IP addresses. ICMP, the Internet Control Message Protocol. The ICMP assists by handling diagnostic and error messages of the IP. Commonly used for ping, echo request or reply, and TTL, exceeds interest route. Usage. It is used for troubleshooting network issues, determining if a host is up or down. Firewalls and routers can block ICMP replies. Traceroute. Traceroute uses ICMP to trace the network route to a destination. Operation. It sends a message with TTL equals to 1, identifying the first hop with an ITP time exit message. Increments TTL to identify subsequent hops until the destination is reached. There is a maximum limit of 30 hops. HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. It uses TCP port 80, also 8008 and 8080. Transports unencrypted website data. HTTPS. It uses TCP port 443. It transports encrypted website data. HTML. Hypertext Markup Language. The HTML is a language used to write web pages. Clarification, not to be confused with HTTP or HTTPS, which are protocols for transferring HTML data. DHCP, Dynamic Host Configuration Protocol. It assigns IP addresses to devices on a network. Operation, it is controlled by a DHCP server. It uses UDP port 67 for the server and UDP port 68 for the client. Application, commonly used in home and business networks for automatic IP assignment. Networking cables overview. There are a variety of cables such as RJ45 copper Ethernet cables are common, but several types exist. Each type offers different advantages and vulnerabilities. There are some security considerations while we choose a cable for our company. EMI or electromagnetic interference and its impact on data integrity. Crosstalk and confidentiality issues. Attenuation affecting signal strength over distances. Twisted pair cables. UTP, unshielded twisted pair cables. It uses twisted pairs of cables to reduce EMI susceptibility. Each cable handles sending and receiving data. Tighter twists, example Cat6, offer higher EMI resistance compared to Cat3. STP, or shielded twisted pair. It includes additional metal mesh shielding for further EMI projection. Thicker, stiffer, and more expensive than UTP cables. Fiber optic cables. Advantages: high speed up to 1 petabyte per second and long distance capabilities. It is immune to EMI. It has enhanced security due to different and difficulty in intercepting signals. Types: single mode fiber, long distance single light mode transmission. Multi-mode fiber uses multiple light modes simultaneously via WDM. Units of measurements and speeds. Measurement units: kilobits per second kbps, megabit per second mbps, gigabit per second gbps, terabit per second tbps, petabit per second ptps, corresponding to increasing levels of data transfer rates. Conclusion: we discussed overview or key IP support protocols including ARP, ICMP, traceroute, HTTP, HTTPS, and DHCP. We also discussed the importance of network cables and their types in data transmission. Key takeaways: understanding these protocols and cable types enhances network management and security. This ends lecture 15. Thanks you and have a nice day.